Good morning, everyone, and welcome to another episode of Dojo Live. Today is part two of a four-part series that we're presenting all about AWS, Amazon Web Services. My name is Kim Lantis, and it's my pleasure to be hosting today along with two very special guests. First, I would like to introduce Art Chan, who is the Senior Partner Solutions Architect with Amazon Web Services. Hey, Art.
Good morning. How are you doing?
Yeah, I'm doing well. Thank you. Thank you for joining us again. We look forward to learning from you. And today we're also going to be speaking with Gustavo Romero, who is a principal DevOps engineer with Encora. Gustavo, thank you for joining us.
Thank you, Kim, and good to be here with you both.
Yeah, thank you. So before we get started with the topic of today, which is all about containers, I would love to get to know each of you just a bit more. If you could share a bit about your stories, your passion, and kind of what's led up to your time with AWS, and that would be great. So we can start with you, Art, please.
I guess this is for those who didn't watch the last one.
Yeah, and if you didn't watch the first one, you can still get a chance, right? You can catch it on our website.
Yeah, certainly been in technology for over 20 years, everything from software engineering to professional services to helping our customers architect technical solutions on AWS and do a lot of stuff on tech on the side. And I think, Kim, you and I talked before the show. I think we're both kind of runners in some sense. So looking forward to seeing you on the start line of that next marathon.
Yeah, I hope so. For a disclaimer here, Art is the runner. I used to be the runner. I'm a wannabe runner today. But great. Gustavo, how about you? Share your story, please.
Thank you, Kim. So yeah, from my side, I've been in industry for over 12 years now, and I started my cloud and DevOps journey about 7 years ago. I got my hands on AWS, and that was when it all started for me. I went and got every certification available, and I think that is something that I'm especially passionate about. Everything cloud, everything DevOps, CI/CD automation, and I also have some experience with security compliance, helping organizations get SOC 2 certified, ISO 27001 certified. So yeah, from a personal side, I'm not so good with cardio as you both. I do bodybuilding though. I do a little bit of cardio, but yeah, hoping to get my professional start in bodybuilding next year. So
wow.
Yeah, that's me.
Wow. All right, well, good for you. And it's awesome. AWS made a great first impression and apparently a lasting one with you. That's awesome. So here we are, like I mentioned, part two of the AWS series. For part one, for those of you who may not have caught it, you can certainly check that out on our website, dojo.live. Search AWS and it will be there. But we talked all about why right now is the right time to be migrating to the cloud if you haven't done so already. And of course, how to get started. For me, I thought it was pretty cool just to learn about how cloud migration can really bring a sense of certainty in the uncertain times in which we all kind of feel like we're in, and just the incredible elasticity, right? This idea of really guaranteeing only pay for what you use, and of course allowing for businesses to better focus on their core competencies rather than infrastructure and other elements. But today is going to be all about containers, and as we've named them, the quote unquote gateway drug to the cloud. Now, we are not supporting drug usage here on Dojo Live, but it is a metaphor that all of us can kind of relate to. So let's do it. But before we get started with why we could consider it the gateway drug, let's talk about containerization a little bit. It's my understanding that this is kind of dominating the software industry. So probably a lot of, if not most of, our users are already doing this, and they're probably already familiar with what the technology is. But just in case they aren't, can you guys offer a really quick summary and some of the benefits, I think, of containerization?
Yeah, absolutely. So if you go back to traditional computing, compute resources were very expensive. Oftentimes you would have to, whenever you're developing a workload or a service, you would bundle multiple microservices onto that same host system. These days, that's irrelevant now. You can then logically partition these services as what we call microservices. They can run in their own, what we call container instance, where you bundle all the libraries and all the prerequisites that are required to run that service into a logical unit. That logical unit can be run on a cluster of servers. And historically, it's been managed in a customer's own environment or in their colo facilities. So they'll orchestrate it using tools like Kubernetes and be able to provide an end-to-end entire workload when utilizing a number of these different microservices.
All right. I think that actually makes sense. And why would one want to do that, Gustavo? Just
Yeah. Yeah. So complementing to what Art already mentioned, which is all true, compared to virtual machines, containers also have the ability to run anywhere and can be quickly deployed without needing a full operating system install or a boot every time a container is launched. So in that sense, containers are really lightweight and they provide a consistent and portable experience for developers, right? And they also provide a strong foundation for any application. I would say most of applications right now that we launch at Encora with our customers are using containers in some form or another. And also something very interesting about containers is that, as Art already mentioned, they can run isolated workloads. So they make a secure choice for any application deployment.
all right. And so for me,
Right,
the non-technical girl, the isolation is like this feature or this launch can happen independently and without potentially messing up the whole shebang. Is that what I'm understanding?
Correct.
Yeah, and there's a couple
Okay.
of reasons and that most organizations would want to do this, because in the past, you frequently saw development teams develop a service. Then that service was then packaged and deployed by a production team. In the middle, there's a lot of hands-on manual work that has to go on by these ops teams, and oftentimes, that's their one-off configurations that are not really well repeatable. So that when you do have outage situations, or if you're responding to an intrusion detection situation, it's very difficult to backtrack and figure out how things were built. With containers, your development and your operations, it's kind of the core of the DevOps philosophy, where your developers and your ops people, they integrate all that into the container itself. So the deployment is agnostic of any manual configuration. And this is at the heart of being able to innovate and iterate faster, because you can then employ these, what we call CI/CD, or continuous integration, continuous deployment philosophy, to rapidly develop and deploy in agile fashion, meaning that you can make small iterative changes over time on your application, instead of having to do one big monolithic release and potentially break 9,000 different things.
Yeah. So, I mean, I guess it makes sense. The name of a container, the visualization here, I always have this like dumbing it down for people like me, but I visualize a brick wall. And so you're really working on a brick. You don't have to take, you're replacing a brick or putting in a new brick, but the entire wall remains standing on its own. Right?
So if I were to extend your analogy, this is almost like a factory build, right? Your developers and your operations teams put together this wall in a factory, and when they take it on site, which would be analogous to your production environment, that wall just stands up. It's running. You don't need to make any changes, right? The difference is, if you had a traditional wall, your bricklayers would lay the individual bricks, and you don't know, was that mortar mixed right? Did they put enough rebar in that course? So, DevOps would be the analogous of a prefabricated, structurally integrity tested wall before you deploy into production.
Nice. I love it. I love it. So enough about containerization itself. Let's talk about sort of what's next. Okay, so we're experiencing this rapid development, the software updates, this prefab awesome integrity wall that just gets popped up. But how can we then maybe run or optimize on top of that? Is this where the cloud's coming in?
The cloud comes in on a couple different angles. Number one, a lot of organizations have realized that running clusters to host these containers, that's a great first step, but it gets unruly really quick. Being able to scale effectively is still a challenge, even though you can scale your number of containers running on your cluster. Scaling the cluster itself is always a challenge. So with that, the cloud comes in and helps out a lot. And in particular, with AWS, we have a number of different cloud offerings. We have 3 different cloud offerings that can help customers with that. Most customers might running an on-prem environment are probably familiar with Kubernetes. So we have a managed Kubernetes infrastructure service called EKS. So customers that are already familiar with Kubernetes, they can take their Docker containers and move it straight into the cloud without much effort. We have an ECS service. This is our own Elastic Container Service, and this is the benefit of running ECS versus EKS is that there's tighter integration with other AWS services. So if a customer wants tighter integration, they could choose ECS instead of EKS. And with both services, the third component is what we call Fargate. Fargate is a serverless container offering. And this is important because what we've heard from customers is, hey, we don't want to manage these clusters. We just want to take these containers and run them somewhere. So with Fargate, you can take your containers and run it on a serverless infrastructure. You no longer have to maintain clusters. You just have to figure out what your networks are, where you upload your containers, and away you go. So it's a very effective way to manage your containers.
That actually does sound very easy, like 3 different choices. Gustavo, as someone who's utilized this service a lot, do you have a personal preference between the 3, or what might be some of the use cases you've used, or to make your choice of which one is the best for any given project you're working on?
Yeah, so I don't have a specific preference. I love both services and the sub option of using Fargate, actually, which is what Art already mentioned, is a serverless platform for running the containers, not having to worry about the underlying virtual machines. But I would say this is a question we always get from many customers who are trying to start in the cloud and already have Docker running. So I don't think the answer is one or the other. You can use one or the other based on your use case. For example, if you have already experience with Kubernetes and even your DevOps team is already running Kubernetes, then EKS is a natural solution for this, because you already have the Kubernetes has a strong learning curve, and if the team already has that, then it's just simple. It's a transparent deployment into the cloud. And also with Kubernetes, it's very easy to have a hybrid workload, right? You can have an application that is running both on premises and in the cloud very easily, because it's all leveraging the Kubernetes API, and it's very easy to integrate between AWS and on premises. And ECS obviously is the other choice. And normally when we want to suggest customers to use ECS, the use case will be when they already have an existing deployment in AWS and they want to integrate with that easily, since ECS already leverages the AWS API directly. It's a more native integration between the services. So it all comes to the use case, right? There's no one or the other. And actually, now that I'm thinking about this, you can actually start with one. You could start with ECS, and down the road you can migrate to EKS, because all the time your building block are containers, and both are managing containers.
Yeah, and I think that's really, really great. I think ultimately, and I think we talked about this on past shows and before the show, it comes down to what's going to be less disruptive for you. And I think you make a good point in being able to be agile, right? Which is kind of what the entire idea about containers and moving to the cloud are. So I would like to take us back a bit to this gateway drug sort of analogy. If if we're already using containers, we see those benefits. And for those of people who might be sort of on this fence of, do we do containers on the cloud? Why is that the gateway drug to the cloud? What is maybe something that this allows that we might not be already experiencing?
Yes. So I don't think this has to be let's boil the ocean and move everything across all at once, even though there's advantages to that. And each customer needs to look at their particular case to see if it'll benefit them. But I would say that most customers that I talk to will eventually run into capacity problems with their own cloud, with their own containers infrastructure. So when they're looking to expand, they have to look at what the total cost of ownership of that cluster is. Their cluster could be very expensive on a per container or per cluster node instance. So in many cases, it makes a lot of sense to take those containers, which are portable in nature, and you can just very easily move it to a different compute infrastructure. AWS is a great choice just simply because of all the containers workloads that run on the cloud today. AWS accounts for 2/3 of all the cloud container workloads. From a pricing perspective, not only are the stock container pricing for running on either a managed cluster or on Fargate really inexpensive, our Fargate instances also have the added benefit of spot pricing. And those who are not familiar with spot pricing, you think of it as excess compute on AWS platform. And if it's not committed, they're made at a significant discount. Sometimes our reserved instances for our EC2 side, you can get up to 70% discount on an on-demand rate. So the idea behind that is, for some customers, they might have some workloads that you can run on a container that can be interrupted. For example, if you're doing drug discovery, where you're doing simulations, you can structure your microservice so that you can run it for a period of time. And if you get interrupted, it's okay. You could stop it and then rerun it later on when the cheap spot compute instances are available. So there are some use cases where you can now move onto the cloud and take advantage of some of these incredible cost savings that you could not do on on-prem, because on on-prem, your costs were all fixed based on capital expenditure instead of operational expenses.
So essentially, you run it for a few hours, you pay for a few hours. That's it.
You run for a few minutes, you pay for a few minutes, right? So
seconds? Are we that granular? No, I'm kidding.
And even
it's
build
down,
second,
so
right?
it's right down to the second billing. And the idea behind that is that in addition to that, not only the second billing, but the spot instances, you're running on reserved or on excess capacity. So if there's excess capacity, you could soak it up at up to 70% discount.
Wow. What other type of testing? You said, is testing workloads and load testing the same thing? I've heard both of these things. I don't know the difference.
Yeah, that's another good example, great example of why people use cloud as kind of a gateway drug, right? Previously, you couldn't effectively do load testing very well on-prem or hybrid, because you would do simulations and you would have, there's a number of services out there that would kind of generate fake load to hit up your application. But they were all simulated, and when you actually put it into production, there were some use cases where your application was load tested, but it would fail when it moves into production. With the cloud, you can actually spin up the right number of instances to do real world load testing against your application. So it's a use case that you couldn't do before because it was just cost prohibitive to acquire the equipment to do that sort of testing.
So load testing is something that I imagine a lot of people are coming up, especially in the e-commerce industry right now with the holiday season. Is that right? Like when we're at full capacity, or let's say, I don't know, Super Bowl like where you expect all of a sudden to have much larger
So
influx.
Exactly.
Is that what that is? Yeah. Okay, Gustavo, go ahead.
So that's capacity. That's capacity augmentation. So in those use cases, cloud is another great example. If you already have a managed or unmanaged container infrastructure, you can augment that through use of a combination of your load balancers, balancing your container workloads that are actually doing the work between a hybrid on-prem, colo, and cloud infrastructure. So that's a good call out. That's another great use case for moving containers into the cloud.
Yeah. Have you used this, or have you seen this play out a bit, Gustavo, in your work?
Yeah. Actually, I was just thinking about one use case that is also very related to what Art has been mentioning, which is machine learning. We can also leverage containers to scale up training and inference models. And what is specific about machine learning is the need of hardware, right? You need specific GPUs or maybe ARM-based devices. That can all run in containers, and you can augment your capacity to run as in the cloud as you need it, right? And you can also leverage what Art already mentioned, which is spot pricing, and only run this whenever you need it. Normally, for machine learning, you will need a large, if you're running it on premises, you will need specialized hardware that may be very expensive, especially GPUs. And in AWS, you can use this on demand. And this is one of another use case that we've seen recently with some of our customers at Encora.
It's a great call out, because machine learning is always one of those where, hey, after I train the model, what do I do with my infrastructure, right? Does it sit around until I'm ready to do another retraining, or what? So with the cloud infrastructure, you can just turn it on for just training and then turn it off when you're done, and not have to incur any additional depreciation on your equipment.
It actually makes me ask this question in terms of business models. Who do you see taking most advantage of this? Is this the small, very startup, very money conscious companies, the mid-sized companies, enterprise companies, everyone? Like who might this benefit the most, or it doesn't discriminate? So, everyone can benefit.
If you take a step back and look at what this is commoditization of compute, right? So the idea is that because it's a commodity now, everybody can take advantage of it. It doesn't matter if you're a operation operating out of a garage, a startup of sorts, or a large enterprise. There's benefits to both. There's the trading in your capital expenses for operational expenses instead. Who doesn't like to have a big win with taxes from that perspective? But secondly, just not having to deal with the undifferentiated heavy lifting, leave that to the cloud. And I can't see that a small company or a large company can't benefit from that.
That's kind of beautiful. I think this was your quote, Art, when we were kind of talking about today's show, and that was this quote of the democratization of experimentation. And I think that's really beautiful. Like, how do you see this leveling of the playing field, let's say, for the future of tech? Like, what does that mean? Like, do we all win?
As a consumer, I would like to think so. But this also means for large and small companies, they're on a level playing field, right? Previously, a lot of these compute-intensive applications were only available to those resource-rich companies that were able to purchase not only the capital equipment, but hire all the advanced technical people that could operate that and to build applications on top of that. These days, with cloud technology, all the heavy lifting of the undifferentiated stuff is done by the cloud platform, and organizations can focus on what their secret sauce is, what their superpower is, instead of having to sit there and configure send mail like we had to do back in the day, right?
Yeah, I think, which actually kind of brings us sort of full circle to the first show on our series, which is just the benefits of the cloud to begin with. Any kind of, as we wrap up today's show, we're actually coming to the final few minutes. We're already 25 minutes in, if you can believe it. Gustavo, in your experience working with containerization, particularly containerization on the cloud, do you have any sort of fun, let's say, before and after stories that you might be able to share with us of what this used to look like versus what it looks like for you now over the course of these last sort of 7 years, as much as you can within, NDA limitations?
Yeah, well, things have changed a lot, and they keep changing now. I remember when Docker was not was only beta, and we were hearing about these stories. And I don't think we have talked about Docker, but this is the industry standard for containers right now. And at the time, you have those options available to deploy everything, but there was not. You would run into all those issues with people making custom configs and not saving it anywhere. Documentation being scarce, and nowadays you have a prescriptive deployment when using containers, right? And on top of all the tooling that we get from cloud platforms and container orchestration tools that come, we have everything automated. It's amazing to see how much that has changed in comparing to the prior early days of DevOps, when you were using Ansible and those sort of tools interacting directly with virtual machines. And now I think the container has become the standard unit for operating small systems, large systems, even thousands of containers in different clusters. So that's something that was pretty much impossible in the early days, because we always thought about, we were always limited to the data center, right? And how much hardware you had there. Now with the cloud, you have many more options, and it truly feels like we're living in a different era.
Yeah, it kind of thinks, if we all can laugh or look back at, the cars we were driving in high school, and then suddenly you get to hop into a Ferrari or something, right? Like how good that must feel for you.
Yeah, exactly.
I love it. Well, any final words from either one of you as we wrap up on what you might do to counsel anyone to make this push toward containerization, and more specifically containerization on the cloud? We covered it all? Okay.
Yeah.
I think there's a delay. Sorry, Art.
Good next steps would probably be to consult with like Encora to try to figure out what services might be applicable, what features might benefit that end customer the most, and then build a plan to do that migration or utilization.
Yeah, I think really great call out. You have wonderful DevOps engineers like Gustavo who can certainly help to get you on your way. I love it. Well, thank you very much. Thank you, Art. Thank you, Gustavo, for sharing your expertise, your experience with us here on Dojo Live today. Again, I would like to remind the Dojo Live viewers that we've got a third part of our 4-part series coming up. It's every other Wednesday, so the next up will be Wednesday, November 30th. And we're going to be talking, I believe, about something that was mentioned on today's show, and that's modernization, specifically microservices and serverless. So don't miss that one, 10 o'clock Pacific, as always. And of course, we do have tomorrow's show coming up as well. That is going to be with Trusty Care and Joseph Schneier. I'm so sorry, Joseph. I do not know how to pronounce your proper last name. He is the CEO of Trusty Care, and we're going to be talking about surprising things we have learned all about health care and how it works. So those of you in the healthcare industry, you're not going to want to miss this one. So thank you, everyone. Stay safe, and we'll see you tomorrow at 10 o'clock Pacific. Thank you for now.